how was lunch? Everyone got the blood rushing to everyone's stomachs now and ready to settle in for a nice little nap? No, far from it. So, this is Win 280. Welcome to TechEd. Hope you had a great lunch. Hope you're having a good time so far. My name is Jim Nee. I'm the product manager for Virtual Server 2005, Microsoft. My co-presenter, who will be joining me shortly, Britt McAllister, Group Program Manager at Microsoft. So what we're going to talk about today, a little bit of an introduction to virtualization as a technology. And after that, we're going to dive into a little bit of what Virtual Server 2005 can do for an organization in terms of improving hardware efficiencies and also reducing administrative costs for running the IT operations. We'll focus a little bit on some of the key scenarios for deployment of Virtual Server 2005. And Britt's going to come up and really dive into the details in terms of the 2005 architecture. We'll talk about some of the key features and benefits. And hopefully at the end of this, we'll have some time for some questions and answers. So virtualization has been around for quite a while now. But up until recently, it's really been kind of associated with the mainframe technologies. But recent increases in terms of the computing performance, the hardware performance, the software performance, everything in that stack has really enabled virtualization to become a key technology that a lot more people can leverage. And a lot more people can now start gaining business benefits from virtualization technologies. So if you think about what has happened in the past with x86 platforms, you've got the hardware layer, you've got the software layer, and for the two to communicate, you've got this device driver layer. And the device drivers really treat the hardware as if they have the exclusive rights over that hardware. It's almost called something like an exclusivity model, if you will. And so what's happening then is when other resources try to get that, to share the rights on that hardware, et cetera, you get these things starting to clobber each other. And so you can actually get some sort of system failure if these models are broken. So with virtualization, and Virtual Server 2005 specifically, what we're doing is really getting down into the lower layers and changing the interaction between the device drivers and the hardware, the operating system, et cetera. And we're doing it at the same time we're protecting the upper level application layers and making sure that they are unaffected by the changes that are going on beneath. So now you can share a lot more of these hardware resources. Excuse me. So with virtualization, the benefits virtualization is that you can now share a lot of those hardware resources, and you can really compress your server architectures, you can compress your application architectures onto single, multiple platforms and really get an outstanding benefit. So Microsoft's Virtual Server 2005 is the most cost-effective virtual machine solution. Three key scenarios that it's really strong in. First is the software test and dev environment. Second is the legacy app migration. And third is the consolidation, server consolidation scenario. All of these three things really combine to help the organization's overall operational efficiency. Another key thing about Virtual Server 2005 is it's a key component in the Dynamic Systems Initiative, DSI, which is a Microsoft-led industry-wide effort to help businesses improve, automate their deployment, their design, and the operations of IT systems. So the first scenario that we're going to talk about is a test dev scenario. Virtual Server 2005 is real strong in this arena. It's one of the key things that we're going to be able to do is go to the application developers, allow them now to consolidate their development environment, whereas before they may have had 1, 2, 3, 4 servers. Now you can consolidate on a single device. This is going to provide greater flexibility. It's going to increase your developer productivity. We have a customer in our TAP program currently in which they are deploying development environments on virtualized servers. And what they're doing is basically when a developer requests a new environment, they basically spin one up pretty quickly. So whereas before they potentially had to deal with hardware procurement, they had to do with then bringing the box in, addressing, all of these things. Now the logistics of that has been shrunken from potentially a day to now possibly 5, 10, 15 minutes. So it really dramatically increases the productivity of the developers and the testers. The second scenario then is with legacy application migration. Frequently, the applications outlive the hardware. And what happens is as the hardware ages, you'll start to see an increase in costs in terms of managing that hardware platform. So what we're striving to do is assist our customers to move off those older boxes onto new boxes that are greater availability, higher scalability, higher performance. And frequently, by migrating these applications onto these new high-performance computers, you can actually even get a dramatic increase in the performance throughput of those older applications. The way that we're doing some of these things, too, with the way that you can build virtual hard drives through Virtual Server 2005, it really allows for the easy porting of these applications over, too. And we're also talking about tools that Microsoft's going to be delivering. One of them is the Virtual Server Migration Toolkit that will help assist in these migrations. And the third scenario is server consolidation. You can consolidate multiple server workloads onto one device. Where Virtual Server is really strong is in terms of consolidating the infrastructure services and disaster recovery environments, and also in departmental and branch office servers. But Virtual Server 2005 is only part of Microsoft's entire server consolidation strategy. Windows Server 2003 is also part of that strategy. It's a very key part of that strategy. There's a lot of workloads that you can consolidate natively using Windows Server 2003. File, print, domain, email, database. Those are applications that really should be using Windows Server 2003 in terms of consolidation. And then there's certain heterogeneous workloads. They're also very viable candidates for consolidation. The key when you're looking at server consolidation is making sure that you're choosing the right tool to assist you in that consolidation effort. So for a heterogeneous environment, we're looking at 3 major ways that you can do consolidation. One of them is through hardware partitioning. Another is through resource management. And a third is, we're here to talk about today, which is virtualization. So if you take a look at the first one, hardware partitioning, our partners, HP, IBM, Unisys, allow you to partition a box into segments of or chunks of 4 processors apiece. There's pros and cons to each one of these ways to do server consolidation, and we'll explore a little bit in terms of what each one brings to the table and some of the deficiencies with that strategy. And that's why I mentioned before it's very key to understand what you're trying to do and how you're going to get there and what are the tools you're going to use in terms of server consolidation. So hardware partitioning is very good for very high throughput applications. By segmenting out the hardware, you're really isolating those applications and really the entire application stack to those 4 procs. Now, on the flip side, the downside of that is that you are segmenting out by 4 procs, by chunks of 4 procs. Resource management. So resource management is available in Windows Server Resource Management. It's great for medium to high throughput applications. And the way that it works is that it helps you control or manage the hardware resources. So whether it's CPU, whether it's RAM. The downfall to that is that it all runs on the same OS. So frequently you might be, if you experience some sort of OS hiccup, it's going to have ramifications to all of the applications potentially that are running on that OS. So that could be a single point of failure. With virtualization, you have the sweet spot is the low throughput applications. These line of business applications, legacy applications that are running on older hardware, et cetera, that you want to migrate over. And those are excellent types of applications that you'll want to consolidate onto single servers. Now, the challenge to virtualization is that, of course, you are introducing another layer into the application stack. And that is going to increase the complexity of the management of that environment. But as Britt's going to talk about in a little bit, Microsoft's creating a lot of tools, MOM and SMS, that will help you manage this environment. And, of course, as you are introducing another layer, it is going to give a little bit of a performance tax. So we're going to start diving into the architecture now. Britt, you want to join us? Again, Britt McAllister, Group Program Manager for Microsoft.
Do I have a mic on? Great. So let me go ahead and pop forward. So let's have a look at the actual virtual server architecture. At the bottom, you've got your server hardware. 2 to 8 processors is kind of the sweet spot that we've designed around. On top of that is Windows 2003. Virtual server, the supported OS, the OS that we recommend is Virtual Server 2003. On top of that, you've got your virtual server service. And so virtual server runs as a service within Windows 2003, which provides in-kernel access to hardware. So what that allows, it allows complete encapsulation between multiple workloads. So jumping up to the very top level there, one OS can absolutely not see another OS because we control it down at the kernel level. It also allows us to do accurate feedback, monitoring of CPU cycles, memory usage, network bandwidth, that sort of thing. So inside of this virtual service is this virtual service monitor that's running. On top of that, we emulate our hardware. So the hardware is very plain Jane. It always looks the same. It's an Intel 440BX motherboard. It's the Intel 21140 NIC card. That virtual hardware, that emulated hardware, is all the OSCs. So when you have a virtual guest running up at the top level, a virtual machine, a guest OS, all it sees is what it looks like as hardware. It uses the exact same device drivers. If I had a hardware Intel 21140 NIC, it would see the exact same device driver. So, and when we talk about virtual machines is a term that gets bounced around quite a bit, and it means many different things. So on one end, people talk about virtualization, they talk about virtual machines when they're talking about non-native binary execution. Okay? And then you sort of move into the next sort of level of what a virtual machine means. You talk about maybe the Java virtual machine or the CLR. And that absolutely is a virtual machine. It has dynamic memory, it has process control, all that sort of what you would associate with being a machine, but you're still in the same, you still have the same network name on the hardware, you're still using the same MAC address on the network card. There's still a large commonality between those two applications running in maybe 2 different instances of that particular kind of virtual machine. Still an opportunity for things to conflict with each other. So then on the very last level, what you've got is the emulated hardware sort of level, where all the applications, the OS sees is what looks like hardware. It's emulated hardware, granted, but there's complete encapsulation. There's no bleed over between the workloads. So that's really important because what we've seen is that with a lot of Wintel servers, we're seeing low CPU utilizations, on the order of less than 15%. Now, not all of them. There's certainly some of your SQL, your exchanges, your Active Directories, very loaded, and that's a great thing for Windows 2003 because it gets better performance out of the hardware in those places. But then there's other applications, there's other uses of the hardware, there's other workloads where we just don't see that bandwidth. And so you've got a lot of this capacity that's going to waste. And what you can do with virtual servers, you can make better use of that capacity. So improved hardware efficiency. That's probably, when I think about why virtual server, why everybody should care, that's the first thing that comes to mind. Is you look at the runaway costs that we experienced in data centers. And a lot of it has to do with real estate and HVAC and providing power. And what this does is it lets you compress and get better usage out of the hardware that you've got, out of the space that you've got. So you go back maybe 2 or 3 years ago and you look at what we had. We had a 4U sort of size server that might have 4 processors running at maybe 750 megahertz. And you look at what we've got today, and in that same 4Us, we can have 4 processors or 4 1U servers. We can have dual procs at like 2.8 gigahertz. The processing power that I can now cram into 4Us is immense. But just take compressing 4Us down to 1U, and you look at the processing power, and in reality, you can move an entire half a rack into a single 1U server, depending on what your workloads look like. Certainly from just a CPU usage, when you add up the total number of cycles, that's an easy one to cross over with. We've talked about some of the initiatives inside of Microsoft to provide better management tools for virtual machines. Now, in reality, we took a very hard, deliberate look at what we want to do around management. And we decided that, with a lot of customer feedback, that the wrong thing to do was to create a whole new set, a whole new suite of consoles that people had to learn. We thought it was much better to work with our existing set of consoles, MOM, SMS, SUS, ADS, the management consoles, ADS, Group Policy Management Console, to just extend what they do so they become virtual machine aware. We've been working with partners so that the partner tools are getting smarter as well. So because you do have to take into account the fact that now I've sort of created this one server that has maybe 8 or 10 different workloads on it. If I'm doing some maintenance to it, I have to take into account the fact that if I take down a service, or I maybe reinstall, if I load a new driver for my network card, my actual physical network card, it's quite likely going to interrupt not just one machine, but the 8 workloads itself. So we took this approach, let's leverage the existing expenditures, the existing investments that people have made in different sort of tools, their training, their certifications, their standard processes, and let's just extend the tools that we have, encourage our partners to do the same thing, so that what you have today is going to carry you into the future as well. So there's a pretty broad set of resource management knobs and dials that you can do with Virtual Server. At the high level, there's sort of the ability to set policy management control based on CPU utilization. So I can I have a single virtual server. I've got 5 workloads running across it. I can say, these 4 workloads are reasonably important, but they're mostly for, testing. They're for the test guys. But this one workload happens to be a production level workload. It's a small company, so we want to put things together to keep things inexpensive. So this one workload, this is really important. I can set minimum CPU levels. So for all of the cycles that become available to virtual server, I can say, I want this particular virtual machine, this particular workload, to get 50% of the processing power. And then I'll give 25% to each of the other ones. I can also set caps. I can say, under no circumstances should this particular virtual machine ever exceed 15% of available CPU capacity. And then the last thing I can do is set weights. So I can say, well, the minimum and maximum is great, but what I want to make sure of is that this particular application, maybe I'm running a 3-tiered, all 3 tiers in the workloads in a particular virtual server, and I know that my bottleneck happens to be my middle tier. So when I do that, what I know that it needs to have twice as many cycles as the web tier and the data tier. So I can set the weight for that to be 50 and the other weights to be 25, and then I'm good to go. So actually back up here a second. So one thing that is important to note when we talk about memory, I've got another slide, I'll hit that in a minute. When we talk about performance, when we talk about the secure isolation and the CPU modeling, the CPU performance policy setting, what that allows is it makes sure that no one virtual machine is ever going to be starved. And when you think about the classic problems in concurrent programming, and one of those problems is deadlock. Doesn't happen. The reason it doesn't happen is because we've got complete isolation. There's no sharing of resources between virtual machines. You think about race conditions. Again, we don't have a problem with race conditions because there's no sharing. And you think about the third problem, which tends to be starvation. And we don't have starvation because we can make sure that every CPU gets a little bit. We can set a minimum level for every virtual machine. I've talked about this. Memory resource usage. So you can set your memory resource for a virtual machine at the virtual machine boot time. Once you set it, it remains consistent and steady throughout that virtual machine's lifetime. You can't change the virtual machine memory while the machine is running. You have to actually bring it down, and then you can reconfigure it and start it back up. So bringing it down is sort of equivalent to a power cycle. Plug more memory in, bring it back up. Memory cannot be over-allocated. So if you have a gig of memory, maybe you want to leave 256 for the host OS, that means that you've got 3/4 of a gig available to allocate to the virtual machines. No way to sort of say, as you can with processing power, set weights, set high-lows. It's got to be hard allocated to that virtual machine. And if you don't have that much memory available in the virtual machine, like let's say that I did have my 256 set for the host OS, and then I had 4 virtual machines, and each one had 256 meg that I allocated for it. Then what that means is I could start the first one, come up no problem. I'd start the second one, it'd come up no problem. I'd start the third one, no problem. When I get to the fourth one, there's no memory left in the pool, and it's not going to start. So in Microsoft, we kind of break the management tasks up into these 3 sort of buckets. And when we craft solutions, when we craft guidance, we always think in terms of this. It's very focused on our MSA, our Microsoft Systems Architecture sort of model. So inside of the deploy, and I'm going to talk about the COM API a little bit in the future, but you've got complete access to the virtual machine service, to the virtual server service. The way that we have architected it is the admin API that you can use to configure the virtual machines with, the virtual server with, uses the same COM API as you can script against. Additionally, all of our internal tools, MOM, ADS, SAS, SMS, that are using the virtual machine service, they go right through the same COM API that all of our external partners use. So you can write scripts to automatically start up a batch of machines, automatically do some policy to migrate a workload from one place to another. You look at one virtual machine, one virtual server host, and you notice that it's become CPU bound. And you can tell that because we export a pretty broad set of WMI counters around virtualization, around the virtual server service. So you notice that on this one host, the CPU is getting maybe up to 85, 90%, and you're concerned that you could start running into some performance degradation problems, some SLA issues. You can actually pause a virtual machine and bring it up on a different host, a less encumbered host. The virtual server does come with an administration console. That administration console lets you manage one host at a time. And then all of your typical management tools that you use are going to work on a virtual server. So one of the sort of buzzwords that we use internally is virtual machine, physical machine equivalence. So a virtual machine, just like a physical machine, use Active Directory or SMS or whatever to manage it. When there's some idiosyncrasies, some differences, we respect those. For instance, and I'm going to talk about SMS in a little while, but just as an example, SMS has an inventory report in it. So we found that a lot of our customers, when we were doing some feedback gathering, we were doing some focus groups, a lot of our customers were using that SMS report, that inventory report, to hand over to their tax guys to do their depreciation. And all of a sudden we realized this is probably not a good idea if somebody's handing this report over and there are virtual machines showing up in that inventory report and having them try to depreciate virtual machines. Sure, the IRS would be unimpressed with that. So, as far as deployment goes, talk about virtual hard drives for a moment. And we're going to get down into the virtual hard drives a little bit because this is actually one of the places where you're going to want to apply a little bit of heuristics, a little bit of rules of thumb to what makes sense when you start to look at workloads. I already talked about the COM API. Actually, there are 3 APIs in Virtual Server, and that's a big differentiator between Virtual PC and Virtual Server. Virtual PC currently has no way to programmatically control the service. Virtual Server, there are 3 APIs. One is the COM API. I'll talk about it a little bit more in the future in a couple of slides. The second one is the WMI API, where you can query, you can find out how many cycles each virtual machine is using, network traffic, disk I/O, all the sorts of performance metrics that you would need to do chargebacks or to guarantee, to report on SLA, that sort of thing. And then the last API is a registry key API. So I mentioned that inside of a guest, inside of a virtual machine, there's no way to tell that you're inside of a virtual machine. So we actually, when you're running the editions, which we recommend because it has dramatic performance improvements, the virtual machine editions, but when you're running the editions, we populate a set of registry keys that applications can then look at and say, oh, am I in a virtual machine? Well, if this registry key is populated, then I know that I am. Which machine am I on? What's my host? This registry key will tell you. And whenever you take a machine down and bring it up on another host, that information travels with it, and when it comes back up, it reports that I'm virtual machine foo, and the name of my host is bar. So had to put those in place because otherwise there's no way to know that you're running inside of a virtual machine unless you try to be clever and say, well, what's the motherboard look like and what's the BIOS look like and some things like that, which probably could be incorrectly pulled together information-wise. Virtual PC, we'll be adding that down the road. They'll be adding a registry key API so that virtual machines will know what's going on, that they're in a virtual machine. So virtual hard drives, they completely encapsulate a virtual machine. So you look at a virtual machine from the host perspective, all you see is a VHD file and a VMC file. So the VHD, virtual hard disk, VMC, Victor Mary Charlie, virtual machine configuration file. There's a third file which is associated not so much with virtual machines, but with networks, and it's called the VNC, Victor Nancy Charlie, virtual network configuration. But these XML files for the VMC and the VNC file store your configuration. So as you make changes to the virtual machine, take it down, as I mentioned, maybe add more memory, create a new network, make network changes and configurations, change names of the host, or actually change names of the VHD file. You'll make those changes inside those XML files. Now that you don't modify the file directly, that's probably not the way to go about it. Instead, you use the COM API. And we actually have events as well that fire whenever the VMC is changed, whenever the configuration file is changed. So each virtual machine can have up to 32 VHDs. 4 of those can be IDE, and the other 28 can be SCSI. You can have up to 7 SCSI buses, 4 disks per bus. We see better performance in the SCSI disk arena. When you create the disk, you can choose whatever you want. So we typically say, SCSI is probably the right way to go. SCSI disk boots just like a regular SCSI disk. It just has better performance, just like with a physical SCSI disk. It's part of the network, the read-write protocol for SCSI. It just has better performance than the IDE. So when you add all this up, 56 terabytes per virtual machine, we really don't see people getting close to this limit. I don't believe that huge sort of scale up either in performance questing or space storage questing is the right way to go with virtual machines. But it's there. Typically, if you're looking for that size of data, you probably need performance to go with it. And one of the current limitations with virtual machines is that they run on a single processor. So they look like a single processor to the OS. So it's a single processor HAL. There are 4 different types of VHDs. And I'm going to sort of hit these out of order. The first one is the fixed size virtual hard drive. You decide a priori, I need a 20 gig hard drive. and it creates a 20 gig hard drive. And just like with any other hard drive, if you use up your 20 gig, it's going to come back and say drive full, volume full, can't write, error, so on and so forth. Now you can actually shut that virtual machine down and change the type of the drive to the next one, which is a dynamically expanding. So in this particular case, you start off with a size, and 5 gig is the size that we start with, and it writes to it. And then it has, just like with a hash table or some other dynamically growing sort of data structures, it has a threshold, and when you reach that threshold, it grows to the next size. So you start with a 5 gig drive, you write 5 or 4.5 into it, and it says, oh, time to grow. It grows by 10 gig, or whatever the limit that you set, configurable. So it grows to 15 gig, you continue writing to it, and then, it reaches the next limit, and it grows to 25. So what the host sort of sees is it sees a single file, this VHD file, that started at 5 gig, and it went along for a while, and all of a sudden it popped up to 15 gig. So you start with a fixed disk, and then at some point in the future you say, you know what? Okay, I'm running out of space. Just bring the virtual machine down. You can change that configuration option, and then it'll continue to grow and live, thrive, and survive as you would hope it would. Linked virtual hard drives is a feature that can be fraught with peril if you don't be careful. So what a linked virtual hard drive is it's a volume on the host that you're going to mount, not as a network share, but as an actual physical partition to the virtual machine. If you mount that that linked partition to the host as well, you can run into data integrity issues. So it makes a lot of sense to use that linked virtual hard drive if the goal is to migrate an existing workload over. I've got my NT4 box. It's running on some old legacy piece of hardware. It's really expensive. I've got to pay hardware assurance on this particular gear. I go ahead and image the boot drive. It's got a data drive. It's got a boot drive. I image the boot drive into a virtual machine. Imaging takes a while. It's actually imaging, doesn't matter which imaging product you use, it's typically much slower than just doing a file copy. So instead, you image the boot drive onto a virtual machine. ADS does this for you. We're releasing Virtual Server Migration Toolkit later this year. And you can actually just pull out the other drive, pop it into the new server, and then from your virtual machine, create a linked virtual hard disk to that volume. Maybe you want to leave it like that. That's okay. We recommend that you go ahead and pull the data off just so that nobody in the future tries to mount that volume from the physical host. Differencing hard drives. Really neat piece of technology here. So what a differencing hard drive is you start off with a VHD of whatever type. Now normally when you have a VHD, all the changes to the VHD are written to that volume, that sort of file system that the virtual machine sees, just like any other regular hard drive. Now with the VHD, when you're using the differencing disk, instead all the changes get written to a separate file. And what that means is that at some point down the future, you can decide to throw those away. So wherever that might be useful. Doing demos, doing hands-on labs, where you always want to bring the machine back to an absolute known state. Test environments. I want to boot up a test infrastructure, 20 machines, my Active Directory, SQL, web server, so on and so forth. I've got 20-some machines. I want to run through a test pass. And then when I shut it down, I really want all that to go away. So that when I come back and I do my testing, when I start over again, everything starts off where it was. As part of my job, I work with some I've targeted and I work with very closely several of the product groups inside of Microsoft. And specifically their test groups to get some feedback, get support for the product, that kind of thing. I recently had an opportunity to go meet with all the test managers in the company, and I sort of, away from just the people that I'd been working with on the targeted basis, I said, okay, test managers, who's using virtual server now, as part of your test process? And pretty much every hand in the room went up. And I said, okay, and who's found it to be effective and made your test process better? Every hand went up. Some people raised 2 hands. So being able to quickly deploy in a matter of minutes, imaging was a wonderful thing. Imaging helped us deploy consistently machines so that we could do things like test and then tear them down and redeploy and do the next thing. Imaging takes time. When you use virtualization for your test infrastructure, it takes on the order of 15 minutes to start up and bring up an entire infrastructure. I'm talking about complex infrastructures too. I'm talking about 20, 30 machines. So the differencing drive, really important in that particular use case, because you want to throw those changes away. If part of the deployment, if part of the test is to go through the install, you want to take it back to a clean, known state. Just makes testing all the much better. The last bit is an undo drive. So an undo drive is just, it's very similar to a differencing drive, except that, again, the changes are saved in an extra file from the host OS perspective. And then when you take the machine down, it just says, do you want to keep these changes, yes or no? And for a demo or a lab, typically you just say no. Difference between a differencing drive and an undo drive, a differencing drive is persistent across sessions. So when I say session, I'm talking about I start a virtual machine up, I use it, I take it back down. That's a session. Differencing drive is persistent across multiple sessions. An undo drive, as you take it down, you get the query, do you want to keep this or not? If you say no, it's gone forever, never to be seen again. So differencing drives can get a little bit, I typically have to make a couple passes through this, so I got an extra slide that sort of shows that sort of concept. So the idea is that from the virtual machine, which is my top little cone picture there, it just sees what looks like a single drive. It doesn't even know that it has a differencing drive. All it knows is as it makes changes, as it writes things to the file system, to data tables, whatever, registry keys, registry hives, everything just happens. Works like you would expect it to. It sees no difference. From the host perspective, on the other hand, there are two files, the main one and then the differencing drive. So one of the things that we look at in testing sort of scenarios is exactly that. You maybe start off with a gold master sort of image, and then you can start to apply service packs to it. So maybe, and you can have one differencing drive, one base drive can be the root for multiple differencing drive trees. So I come from a programming background, software development background. In my mind, I think of the base drive as a superclass, and then I'm just subclassing the trees, creating a whole class structure of drives, of applications. So at some point in the future, you can unwind it, throw the undo drive away. Then I think my next graphic here just shows the concept of, so the one over to my left that's in green there is that you can have one master that can serve as the root for multiple chains of these differencing drives. Pretty valuable technology. Like I said, our test managers have just loved this particular feature. Virtual networking. So inside of a virtual machine, it sees a NIC. What happens between the virtual machine NIC and the actual NIC that's plugged into the hardware? There's a lot of details and a lot of ways to configure this. So from in the virtual machine service, you can create virtual networks, as many as you need. You can bridge the virtual machine NIC directly to a physical NIC. You can bridge multiple virtual machine NICs to a physical NIC. You can bridge a network to a NIC. So this gives you a lot of different ways to do it. You can set yourself up so that I have a virtual machine and it just sees the network, doesn't even, from a perspective of another machine looking at this virtual machine, it looks like it's on the network. I can create networks inside of my virtual server between virtual machines where no packets ever leak out onto the physical device, onto the physical device NIC or onto the physical device network. I can do guest to host where I don't see the outside network, but I do see the host. So that gives you like an interesting way to maybe bring up virtual machines in sort of a quarantine mode where you want to be able to see the host because maybe that's where you've got some patches or something like that, but you don't want it to see the NIC. So it gives you sort of a safety sort of place. Each virtual machine can have 4 NICs. As I mentioned, each NIC can either convert to a virtual network, it can bridge to the host adapter, it can go nowhere. There is support for teamed NICs. One of the things that we have been working with is working towards load balancing. And we're not quite sure if this is going to be a supported scenario yet, but we're working with the NLB team to bring that online. Inside of the virtual networks, inside of the virtual server service, there's a DHCP server. So you can have full NAT capability through the virtual service. So you can have n number of virtual machines that don't have actual physical addresses. Then you can use the NAT that's part of the virtual server. If you choose to have the virtual machines just communicating guest to guest, as like I mentioned, one of the ways that we do support, like I said, no packets fall out onto the physical network. So we have this concept of creating virtual machines that have infections, so that then we can test to make sure that if we bring up like a particular server in that environment, it's going to be safe. So again, from a testing perspective, from a reliability, from a trustworthy perspective, we're seeing a lot of usage, a lot of capability in virtual server. Wow, big architecture diagram. The other thing I really want to touch on here is just that there are 2 drivers installed into the host OS that make a small change. One is the VMM service, the system driver, that actually handles running inside of kernel mode. It handles this sort of dispatching of moving the CPU from one service to a next. Because when we run a virtual machine, when the virtual machine takes over and runs, we actually tie the virtual CPU to the physical CPU. So you get a very small performance hit. There's always a tax when you virtualize something, but it's a very small one. And the other one is the network driver, which again gets installed at the host level. And that's so that we can provide this firm encapsulation, make sure that packets don't spill across, and do the WMI counters that we need to be doing so that you can track your SLAs and your chargebacks appropriately. The COM API. As a developer, this is the part, or as a former developer, this is the part of the product that I really love the best. So again, you can script it. And we've had numerous groups build sort of interesting tools inside the company. There's a myriad of uses for virtual server that we haven't even tapped because we've really focused on those 3 scenarios of server consolidation, legacy app migration, and app dev test consolidation. And the reason why we've just focused on those is we wanted to get really deep with understanding all the issues and problems that people might run into, making sure we had prescriptive guidance lined up, making sure that we had like really good, firm understanding in those spaces. We've already seen numerous groups inside of Microsoft and numerous groups outside of Microsoft as well who have built interesting, sort of compelling applications around it. An example, one test group built a little web UI to a system. They click on the button and it automatically goes off and starts up a bunch of virtual machines for them. It's like, I want test infrastructure 1 through 17 or whatever they've got. And they can just click it. It goes through, starts up the virtual machines, configures the network, and passes them back the information so that then the test engineer can go do their job. From a deployment standpoint, deployment operation standpoint, I mentioned that we can migrate existing workloads into virtual machines. You can deploy to a virtual machine just like you can a physical machine with one gotcha, and that's that the Intel 21140 network card doesn't support Pixie boot. So you mount a RIS floppy and you boot into a deployment agent that way. Operationally, moving a virtual machine from one server to another, moving a workload from one server to another, just looks like pausing the virtual machine, going to the next host and starting it up over there. Now, when I talk about pausing a virtual machine, and this is like a really sort of compelling part of one of the operational things you can do with virtual machine, is because it basically provides you with ILO, integrated lights out capability for your virtual machines. So not all servers that we have in our data centers have ILO, which that means is that if a server is poorly behaved, it's got a poorly behaved application on it. For whatever reason, it becomes non-responsive. That means you've got to send somebody to the data center, potentially send somebody from their home to the data center just to push a button to reboot the machine. When you've got a virtual machine, when you have a virtual server with a virtual machine on it, you have the capability to start, stop, pause, and resume virtual machines. So you get that big red button that you can push. Now, we've put plenty of security in place so that people can't reboot your servers for you. As a matter of fact, one of the things you have to have for a virtual server is you have to have admin, your user context has to have admin privileges on the box to be able to use the COM API, use the admin console, those kinds of things. But what pause looks like is it's sort of like Hibernate on your laptop, only better. Because what it does is it actually waits until there's a clock cycle, it pauses on the clock cycle, and then it literally takes every byte of memory and writes it out to the disk. So to the guest, to the applications, all they see is one long clock cycle. They don't notice anything. Now, if you have an active network connection, your mileage may vary. But all that memory gets written out, and then when you resume it, it just brings it back in, and like I said, to the OS, to the applications, it doesn't look like anything happened. All it saw was a clock cycle, and it just happened to last a very long time. And in any application, there's always a variable with how long you get between when your service with CPU cycles. So no big deal there. 42 interfaces in the COM API. There's literally hundreds of methods associated with it. Just like any COM API, it has sort of a hierarchy. You start with your virtual server object, and then the virtual server object has enumerations for virtual machines, so you can go find a particular virtual machine. It has enumerations for your network, so you can go find a particular network. It has ways to create new virtual machines, so you can actually dynamically rack hardware. So think about you wanted to create a web application. You've got a bunch of developers and test engineers, and they want hardware. And so instead of actually them filling out a web form and you sending that off to one of your OEM providers, getting the hardware in, comes in the loading dock, and you rack it up, and they get their server. Instead, then when they fill out there, I need this much memory, and I need this much, in the way of CPU, or this much disk space, or whatever. You take that information, you access the COM API, dynamically create a new virtual machine, start it, and then you can come back in 15 minutes, or actually less time than that even, and say, okay, developer, tester, whatever, here's your new piece of hardware. Install the OS, or we can install an OS for you, whatever on top of the metal sort of operations you might need to take. Virtual machines. One of the things you do with the COM API is there's events that happen, events that on triple fault, when it begins to shut down, you can catch an event. There's events for when the configuration is changed. The virtual server service, one of the interesting things you can do there is, again, is you can set the preference for how virtual machines react whenever the service is going down. So you can tell, like when the service is going down and the virtual machines within it need to do something. So you can tell them to pause, you can tell them to shut down, or you can tell them to reset themselves, whatever. And then when the service starts, on the other side, you can do the same thing. You can say resume yourself or start virtual machines or whatever. So if you had a power failure and you didn't have your UPS running, shame, then what that means is, well, then you would just lose everything in that particular situation. Let's take that where you did have UPS, and the UPS would then warned you and said, we have a failure coming on, then the service would start to shut down, and you could pause the virtual machines, and then when power came back up, they would just come back to their same state. The COM API, as I'm sure everybody knows, it can be accessed through VBS, C#, C++, scripting, whatever. I mentioned the virtual machine website earlier. So it's a web-enabled API, a web-enabled admin interface. It looks at one virtual server at a time. We really look to higher-level tools to sort of provide the management of a farm of virtual machines. We've been integrating our tools so that whenever possible, they just treat a virtual machine like a physical machine. However, if there's some differences that they have to respect, for instance, with ADS is our imaging tool, Automated Deployment Services. It doesn't have PXE. The Intel card doesn't have PXE, so we use the RIS floppy to boot it. MOM 2005 has a management pack, which looks at a virtual server, and you can use it to set up policy-based rules for migrating workloads from one server to another, calling out issues. And then SMS and SUS, you patch virtual machines just like you would physical machines. The only thing that I really want to mention on this site, because I've sort of gotten a little bit out of order on these, is the VMRC. And what the VMRC, Virtual Machine Remote Console, allows you to do is you can actually just go to a web page and open up a console directly to the virtual machine. So when you're booting, you actually see the boot prompt, which is kind of nice, actually, when you think about it, because it lets you have access to the virtual machine before maybe you had an RDP running or a shared sort of desktop protocol. Now, if your virtual machine has the capability of running RDP, or if it's Windows 2003 and you want to make it a terminal service server, or you're running Windows XP and you, enable shared desktop, then you can just term serve into it just like you would any other physical box. But what the VMRC allows you to do is actually grab the S3 video card output and blast that into a window. And typically, although there's a special console you can use, just like a term serve kind of thing, typically we just use a web page. We have an ActiveX control that lets you look at that. And like I said, the neat thing is if you wanted to make PROM changes or EPROM changes to the CMOS, you wanted to change the boot order or something like that, you can actually get control of it as it's booting up when you see the Phoenix BIOS or whatever come up. Active Directory, again, virtual machine, physical machine equivalents. A virtual machine looks just like a physical machine. So you use your group policy management console. You can delegate administrative rights to virtual machines just like you can a physical machine. Now there's two things that you can actually set a little bit different, the sort of extensions that virtual machines allow that you can't do with a physical box. So you can set your virtual server up so that only certain people have the ability to create new VMs, which is a compelling thing to do. You can set it up so that only certain people have the ability to punch that big red button and restart a machine or pause a machine. Maybe in your environment you want your administrators to have that authority and not necessarily each and every individual developer, tester, program manager, whoever. It also lets you have the ability to decide who makes changes to the configuration for virtual machines. So you can control and you can create protected steady state configurations and infrastructures. And then just like with regular machines, you can control who can log into a machine and who can, what permissions they have when they log into the machine. Now there's one other sort of place where you can set some permissions, although it's something that to be approached with caution. And you can set the permissions actually on the VHD file. And the reason why you might want to approach that with caution is because you can create a read-only virtual machine. And we don't recommend that you try to create read-only virtual machines. We recommend that you use the differencing drive or the undo drives rather than trying to set file permissions and create a virtual machine that just can't be written to. It creates for a confusing user experience when they see the undo. Do you want to save these changes or not? And they say yes and they don't get saved. It creates for a confusing user experience when they install patches and those patches don't persist. So don't recommend doing that at all. MOM, as I mentioned, has a management pack for virtual server. You can have it report back the guest host mappings. The WMI counters, the WMI API that virtual server provides. MOM accesses that to provide reporting on how many cycles a particular virtual machine is using. You can track what it's looking like, how much disk bandwidth it's using, network bandwidth. So we really see that as an opportunity to take that information and roll it up and create like departmental chargebacks. So it gives you like a nice way to roll that information up and say, okay, for this particular server, because it's hard to take a particular, when you have each department has their own set of servers. You know exactly what they're using, and you can bill them appropriately. But when you take two sets of departments and you migrate them onto one virtual server host, you've got to find a way to sort of say, you're using this much of the capacity, we're going to bill you this, and you're using this much. Tracks events, you can set it up, like I mentioned, to do policy tracking so that on a particular CPU load level that you might migrate a virtual machine from a fully encumbered host to a less encumbered host. ADS, our automated deployment services. We have a toolkit that we've built that handles migration from legacy situations so it works with NT4 to Windows 2000. So you can migrate existing workloads into virtual machines. So what that looks like is we run a hardware gather on the existing hardware, and then we've got a set of recipes that we know don't work. Like if you've got an attached tape drive to that particular server, there's no way we don't virtualize tape drives in the virtual server platform. So you check your hardware, run it against a pre-flight. Looks good. You image it, and then you take that hardware gather that you ran and use that information to virtually rack a new virtual machine. Just has to contact the COM API. Racks a new virtual machine, and then it takes that ADS image and applies it to the virtual machine. Restarts it, applies patches, fixes up the HAL if it needs to. You may be going from a dual processor NT4 box with 300 megahertz processors to a single processor VM. So we change the HAL, do all the HAL fix-up, do the device driver fix-ups, all those kinds of things for you. Currently, we're in customer trials with this tool right now, looking at beta shortly and release later this year. Beta in Q3 '04, I guess, is the schedule. That's Q3 calendar year '04. SMS, like I mentioned, one of the things is you patch a virtual machine like you would a physical machine, and then we also call out in the hardware inventory report the fact that these are virtual machines rather than physical machines. There's a new type of node that is a virtual machine. You use SMS to call out the host machine, guest machine relationships, because that matters how you patch things. So what you don't want the situation to be is you just blast patches into your virtual machine and virtual server environment, and the virtual machines get patched and the virtual server gets patched, and it's non-deterministic, and maybe the virtual server reboots because this particular patch required a reboot in the processor. Maybe there's a network driver that gets reinstalled and it shuts down the network. So you don't want that situation. Instead, what you want to do is you want to use that information to sort of say, okay, I want to patch my virtual machines, patch, pause them, makes good sense, patch or if they need, let's say they need a reboot, which is the more compelling case, so patch the 4 virtual machines, or 5, or 1, whatever that number is, shut them down, patch the host, reboot it, and then when the host comes up, it brings the virtual machines up with it. That's where you would use that information about guests and hosts. As I've been saying over and over again, virtual machine, physical machine equivalence. What you're going to see in the future is that almost all of the providers of management tools, consoles, are going to have support for virtual machines. In fact, most of them are going to support virtual machines today. And then there's going to be some extensions to these tools to exploit the really cool things you can do with virtual machines. Being able to move workloads, being able to adjust the knobs to balance what a workload looks like. So, back to you, Jim. You want to talk about partners?
Yeah. As Brett mentioned, we are building an entire ecosystem around Virtual Server 2005. It includes a lot of the solution software vendors, includes OEM partners, includes system integrators. Furthermore, Microsoft's also developing its own prescriptive guidance that helps our customers figure out what to do with Virtual Server 2005 and the new abilities that it can really add to your organization. So as I mentioned before, I think you've identified, or hopefully we've been able to communicate some of the things that you can do with virtualization, and specifically with Virtual Server 2005. You now see how it can be a key part of the Dynamic Systems Initiative, the ability to spin up new applications in the snap of a fingers, things like that. You know, it really fits into how we're trying to allow businesses to design, automate a lot of their IT systems. So, in summary, the key things that we're trying to accomplish with Virtual Server 2005 is improved hardware efficiency, so allowing you to consolidate a lot of the resources onto single devices. We're increasing productivity through a set of administrative tools, through the dev test scenario, et cetera, in terms of being able to bring up these applications really quickly, manage them, bring them to market more quickly and efficiently. And we're creating an entire partner ecosystem. So these are the three key things that we're doing with Virtual Server 2005, which is going to add benefits to our customers going forward. So we're pretty much done with this presentation. There's a host of community resources out there on the Microsoft site right now. And I think in all of the TechEd kits, there's a Virtual Server resource kit that's got a lot of the white papers, data sheets, and things like that. But there's also community groups. And on that CD, you'll also see that you can go to www.microsoft.com// Virtual Server, and you can get a lot of the up-to-date information about where we are with Virtual Server 2005. So I think we have some
about
time.
5 minutes.
We have about 5 minutes for some questions.
Yeah. How does Virtual Server work with clustering environments in terms of, and I'm not clear if it has support for shared disks or not, so you can actually move shared disks between virtual servers.
Actually, that's a great question. I think Robert Larson, member of the ICE team, do you want to address that real quickly, Robert?
Sure. Actually, to get real detailed information, there's a session tomorrow on exactly that topic, on how to cluster. Actually, I'll walk through a demo and everything. But if you look at the product, since we have the support for SCSI, we have up to 4 SCSI controllers. Each SCSI controller can be configured as a shared or non-shared. In shared mode, you can attach one shared disk to it, and that disk can be shared between 2 virtual machines in a clustered environment. So I can take one cluster or one SCSI controller, turn it into shared, attach a virtual hard drive to it, and that can become my shared quorum disk. And I can take another SCSI controller, attach a virtual hard drive to it, assign it as shared. I get a shared disk, so that I can have up to 4 in this scenario.
And the follow-up question is, those shared disks that you're describing, are those LUNs or are those actual logical drives?
They're seen as LUNs.
Okay, thank you.
Hey, Robert, when is that Virtual Server clustering presentation tomorrow? Oh, I'll put you on the spot.
Yeah, he put me on the spot.
Okay.
It's
okay.
Let him look it up.
It's after
we'll
lunch.
look it up.
How about in the back there? Sorry.
Hear me?
Yep.
Okay. I have 2 questions. The first one's an easy one. Jim, can you spell your last name?
Yeah, mine is Jim Nee. Last name is spelled N-I.
Okay. Thank you. And the more difficult one, perhaps, is one of the main things that distinguishes the VMware line of similar products from yours, as far as I can tell, is at the high end, they have an enterprise-type server which actually acts as a fully self-sufficient hosting environment into which you install the guest OSs. And I wondered what your comments are on that architecture and if Microsoft was planning anything similar along those lines in the future.
I think right now with Virtual Server 2005, we're really focused on the 3 scenarios that I mentioned before, which I think addresses their GSX product. I think the ESX product is an interesting product in terms of what it's trying to do. But based on the information that we've received from a lot of our customers, analysts, et cetera, it's at this point not something that there's a mass migration towards. And so what our goal is really get Virtual Server 2005 out there, get the customer feedback, as we traditionally do with all of our products, and then build whatever functionality is necessary to address the customer needs. So if it proves out that that's absolutely critical for our customer base, then we certainly will try to approach and build whatever functionality it is that addresses it.
I have a question. Over here. Left.
Oh, okay.
The question is more on iSCSI and Fiber Channel. Is there any support for those type of MPIO and that type of stuff? Will the virtual servers be able to emulate that type of protocol at that level?
So I'm going to dodge the iSCSI one and address the Fiber Channel one instead, because the answer is no on that. Because what you've got to do is you've actually got to emulate the host bus adapter at the virtual hardware and platform level, and we're not doing that currently.
Okay.
Okay?
And the iSCSI? Just complete dodge.
I'm going to dodge that right now.
I have a quick question regarding pricing. So one of the things that's kept us away from VMware is the price at the enterprise level. So do you have an approximate price range at this point?
We don't have that disclosed at this point. We're looking at launching the product in the second half of this year, and at that point we'll have all of the availability and pricing information.
Okay, thank you.
Thank you. Two more, please.
Yeah, I have a quick question. Is it possible to install a physical modem or such device within a virtual server environment? Is it possible to install a physical modem or such device within a virtual server environment?
Physical modem? Yeah, you have access to the COM ports. So as part of the virtual server hardware that you use, some of it's emulated and some of it's bridged over. So you bridge over to your network, to your keyboard and your mouse, to your parallel port and your COM port, so you can use a modem in that way.
Okay. One more in the back.
Yes, I have two questions. Number one, you mentioned that each virtual machine can handle only one processor, or can you assign 50% of each processor in a quad processor server?
So I heard the part where you said each virtual machine has one processor, and that's true. And then I didn't catch the rest of what you said.
Can it support more than one?
Not in Virtual Server 1.0.
Okay, when is it going to support more than one processor?
We're looking at the customer demand on that, and based on what we hear, we'll decide, do our product planning for the next version.
Okay. My question number two is, do you have any integration with Citrix MetaFrame?
I'm sorry.
I can barely hear. Can you turn up the volume on those? Oh, could you step closer to the mic, please?
Sure. Do you have any integration with the Citrix MetaFrame?
Citrix
MetaFrame. So actually, we are looking at a lot of the ISVs to partner with, and so Citrix is one of those vendors that is looking to optimize their application for virtual server.
Thank you.
Okay. Welcome. Thank you, everyone. Enjoy TechEd.